Question 3 in the mark scheme can be bullet pointed into 7 tasks. The available marks can be seen in a detailed mark explanation. The first 5 tasks are 1. Fixing runtime errors by coercion of input to int. This means changing the data type of the input to integer. 2. Fixing errors by using modulus. 3. Use of at least one appropriate if statement in the solution. 4. Adding validation for input numbers. And 5. Correct output messages. For question 3, 2 level-based mark schemes also apply, one for solution design and one for functionality. This is the original question from the GCSE 2020 Computer Science Specimen Assessment Material. This question gives students an opportunity to demonstrate the skills mastered during program development. There are errors to fix and amendments to make to ensure the program behaves appropriately. Careful reading of the question also gives information about the test data and the fact that checking input for the wrong type is not required. What this means is that the program does not need to check that the input is a number. This is a file that the students are given during the exam. This question provides code that may be functional in parts. Students need to fix errors, amend existing code, and/or small amounts of code to meet the requirements of the question. This slide shows student response A. Marks for this particular response were awarded as follows. For the first bullet point, 1 mark was awarded for using the function int on line 11 to coerce or change the input data type from string to integer. On line 15, no marks were awarded for the use of modulus, as normal division was used here. 1 mark was given for the use of if, elif, else on lines 13 to 17. 2 marks were awarded on line 13, 1 for the Boolean operator or, 1 for the relational operator less than 1, but no mark for the use of greater than or equal to 20, as they should have used greater than 20. No marks were given for correct output messages, as the error on line 13 causes them to be incorrect. 2 marks for design were awarded, as the problem has been decomposed. The choice of programming constructs is appropriate, and the logic is clear, even though it was implemented incorrectly. Only 1 mark for functionality was awarded, as while valid input is processed, so is invalid input. The total marks are 7. You or your students may wish to annotate onto this example where the points have been awarded, and then look at how they might improve them to score a higher mark. For response B, marks were awarded as follows. 0 marks for coercion of string input to integer on line 10. On line 16, 0 marks for modulus operator as it has not been used. 1 mark for the use of an if statement as the if-else on lines 16 to 19 is constructed correctly and used in the correct logic, even although the conditional test is incorrect. 1 mark for the relational operator less than 1, and 1 mark for greater than 20, but there is no Boolean operator. This is on lines 11 to 13. 0 mark for correct output messages. 1 mark was awarded for design, as there is an attempt at decomposition in the implementation of the range check. 0 marks were awarded for functionality, as the program does not complete running. The total marks are 4. Again, review the mark explanation document for additional explanation, including how this candidate could have improved their response. You might want to consider how different this response was to the first, and again, how you might improve this response to achieve higher marks. This type of question simulates the development process that students will have encountered during their class lessons. There are runtime and logic errors that need to be fixed to create a functional and accurate solution to a problem. There are amendments needed to ensure the program meets all the requirements set out in the question. Students are provided with a bulleted list of requirements. The inputs and outputs are described. Note that comments are included about the level of validation needed. For example, only a range check is needed, not a type check here. As always, the best way to create a question of this type is to start with a working solution. Decide how many, if any, of each error type to include in the mark scheme. Decide if you'll include any of the levels-based mark schemes. Ensure that the actual solution is accessible so that students don't need to devote a large amount of time to analysis of the problem before they can understand what is required. Ordering the bullet points in the order that they need to be addressed will provide students with further clues to addressing this type of question. For example, fixing all the syntax errors first might be appropriate just to get the code to run. Then, tackling the logic errors might be the appropriate next step. Solutions like this give students the opportunity to demonstrate skills in the development of working solutions. You can use this flowchart as a step-by-step process to both support the creation of this question type and also the decision-making behind creating an accessible and challenging question for your students to complete.